Hello, this is Math 2231 coming to you from the College of DuPage during the summer of 2020, and this is the conclusion of the lecture entitled Areas Bounded by Multiple Curves. When last I left you, you were working on this problem. I hope you finished it, but just in case not, I'll give you another chance. You know what to do. Let's see how you did. Well, first I would graph it, and I see that the blue curve, the line, is above the parabola, and this is the green area that we're seeking to find. So this is going to be on top, this is going to be on bottom, so we're taking the upper function minus the lower function. Well, we have to know what are these limits of integration. So this is y is equal to this, and this is y is equal to that, so I set the two y's equal and solve by factoring for the x's. So the x is going to go from minus 1 on the low end to 3 on the top. Now the upper function is 4x plus 16 minus, and this is important, this is minus the whole of the lower function. So it's minus parentheses. That's a mistake students often make. And then you should go through and verify these calculations. But the area that we're seeking is 64 over 3. Here's another problem for you guys to do, so read the problem. You know what to do. Let's see how you did. Now, you realize that the functions are the same, but the limits are different because we're going from minus 2 all the way up to 5. So when we look at the graph carefully, we see that over here, the red function is above the blue function. In here, as we saw before, the blue function is above the red function, and we don't really have to compute this again. That will be the same as what we did before. And here the red function is above again. So that means that we have three integrals. So the area is going to be, this is going to be the first of those integrals. This is going to be the second integral, and this is the third. So we go through and compute them, and notice each time it's minus the whole of the lower function. So we do algebra. Here's another problem for you to do calculus, and then we do arithmetic. Let's see, and the answer to this is 142 over 3. Well, here's your graph, and you see that the cosine is above the sine for part of this, but then the sine is above the cosine for the other half of this. And you might speculate that those two areas are equal, and in fact they are, but you'd have to, you could certainly demonstrate that. In fact, I guess we demonstrated here. And you also have to know where do these intersect, and so you set sine of x equal cosine of x, and you solve, and it's pi over 4. So we're going to integrate from 0 to pi over 4, cosine minus sine of x dx, and then from pi over 4 to pi over 2, the sine of x minus cosine of x dx. We find the antiderivatives, and we plug in our numbers, and what we get is 2 root 2 minus 2. We're not going to be using this decimal expansion. That's an irrational number, and that's how you'll leave your answer. Number 6, you want to find the area enclosed by these two curves. You know what to do. Let's see how you did. So this is the graph of our function here, and we can determine where these curves intersect. Now what I do here is I say that y plus 1, I solve this one for x, and this one's already solved for x, and I set those two values of x equal to each other, and I solve this. Now this ends up being a quadratic with fractions, and you get rid of the fractions, and then you can factor it. And so you got y is going to be 4, or y is going to be minus 2, and we can go back and figure out what x has to be. So these are the 2 points of intersection. But now we have an important choice. We can go dx, or we can go dy. Let's look at the dx scenario. So here what happens is If you start going along the x-axis, you're drawing slices like this, and so you see you're going from -3 to -1, and you got red is on top and red is on bottom. From -1 to the rest of the way, you have the red on top but the blue on bottom. Now dy, so there's two integrals that we would have to do. If we look over here for dy, you see the blue is always the greater value. Now this way, what I have to do is I'm integrating dx, and I know I have to go from -1 to 3, but this is going to go from -1. We're going to do it both ways. But now I have to solve it here, because if I'm integrating dx, the way I drew the slices, these have to be functions of x. So you see the function on top is going to be positive square root of 2 plus 6, and the function on the bottom is going to be minus square root of 2 plus 6, and we take the top minus the whole of the bottom, and here on the top is this one, and the line is on the bottom, and again it's the top function minus the whole of the bottom function. Now the rest of this is doing algebra and calculations. You should verify all this. That's good practice for the final. But this is what you get when you do the algebra, and this is what you do when you do the calculus, and we get an answer of 18. Now if we do it the other way, what we're going to do is we're going to be integrating dy. It's going to be the right function minus the left function. There's the right function minus the whole of the left function, and y goes from -2 to 4. Those limits are dy, so these limits are y. So then when I do the simplification of this, I get this. That's algebra. Then I do some calculus. Then I do some arithmetic. And I again get 18, which I hoped to do. Here is one more example. You know what to do. Let's see how you did. So I can go dx, or I can go dy. Over here, I can have red on top, red on bottom, blue on top, red on bottom, blue on top, blue on bottom. 3 integrals. Over here, the same function is on top the entire time. The blue one is, and it's not on top, it is rightmost minus the left function. So dy is a better choice, and we're only going to do one. You're welcome to go and try to do the other one, and I encourage you to do that. So here we go. It's going to be the integral from, this is going to be -1 to 3. Those limits are y's. It's going to be the right function, minus y squared plus 10, minus the whole of the left function. So I do some algebra, then I do some calculus, and finally I do some arithmetic. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now, more than ever, take care of yourself and of each other.